Are you planning to soundproof a louvered door or a window? Well, I interviewed Lisa Schott, who's a soundproofing expert, and we're going to talk about the most common mistakes people do when they're soundproofing. So stick around to the end because we're also going to mention a lot of very useful tips that you should be aware of when you're soundproofing your louvered door or window. So let's go to the interview. I know you've worked with this construction of yours that looks like a louvered window. And could you tell me a little bit how you work with louvered doors and louvered windows and how it works with soundproofing them?
Oh, sure. Well, the product that I've developed is shut-eye acoustical shutters, and this is a sample of the
Mhm.
shutter. It was designed primarily to be installed in exterior windows and doors to block out sound from any type of exterior noise source, such as traffic or trains or airplanes. But some people have installed them indoors as well. For instance, if you have a loft room, an upstairs room that looks over a two-story space, oftentimes there's just an opening in the wall. But sometimes that might be a bedroom upstairs and a living room downstairs where people are making noise and watching TV or listening to music, and you want to
Mhm.
be able to block off that loft opening. So some people have used these acoustical shutters for that purpose as well.
Mhm.
So the reason I developed them was a friend was looking for a solution to block exterior noise, and I looked in the marketplace, and I could find all kinds of shutters and even curtains that claimed to be noise reducing curtains, but nothing was really providing as much noise reduction as I needed to help my friend.
Mhm.
So I decided that I knew how to solve this problem. And even though I couldn't find something on the marketplace, I could come up with a design solution myself. So in one of my employees' garages, we built a prototype of the design, and it was basically a multi-layered solution with acoustical barrier materials and absorbers inside of it.
Mhm.
And we put it in the window, installed it, and on hinges so it could operate. You could open the panels or close them, and it blocked out so much noise that sounded like from going from a busy highway, it now sounded like a quiet forest in his condominium. So once we had that prototype, yeah, we proved the technology. We were getting up to 40 to 50 decibels noise reduction in certain frequencies, which is a gigantic amount of noise
Yeah.
reduction. So we said, well, the prototype, it was built in a garage. We need to make it look a little bit better. So we said, well, this concept really works like and operates like plantation shutters, like the decorative shutters that everybody's used to that look a lot like these.
Yeah.
Some of the big differences, though, is our louvers are actually fake. They don't move, they don't tilt and rotate. If
Mhm.
they did, that's one of the major sources of noise leaks in regular shutters. And our acoustical materials are behind here, so you can't see them, but the aesthetics is pleasing because people are accustomed to what plantation shutters look like. So they look like they're plantation shutters in your window, but they do a much, much, much better job of noise reduction. And they also, a lot of people install them in bedrooms. They
Mhm.
block out all the light, so you can get a nice quiet. Not only is it blocking noise, but also light. And then during the day, when the noise is not as bothersome, you can open up the door panels, and of course that lets in the light and the noise.
I see. And yeah, I wanted to ask you specifically about louvered windows and doors. If you could tell me if is there any way you can actually soundproof it? Because I know that one of the basic principles of soundproofing is that you shouldn't, if you can let light in, then you will definitely let sound in. So is there any way to soundproof a louvered window or a door?
Yeah, louvered windows and doors are problematic just for the reason that you've said. There's so many joints and connection points that where light can come through and also sound. You really need to do something like what we've done with the acoustical shutters is add layers of some sort of barrier behind those louvers, which
Mm.
would then of course kind of defeat the purpose of louvers. But just
Yeah.
having louvers or blinds themselves, it's incredibly difficult to soundproof those. I actually looked into that when I was inventing this product.
Oh, cool. All right. So, but okay, so. it sounds like if you're really into, you've just determined that, all right, you're going to soundproof your louver door, then on the outside, it's only going to be aesthetics, but on the outside, you're just putting a lot of materials in order to soundproof, correct?
Right.
Okay, so what materials would I need if I want to put on the inside of the louver door or window in order to soundproof it in the best way?
Well, that depends on what type of noise you're trying to reduce and how loud it is. As we talked about earlier with trying to soundproof between two spaces in a home, you need massive and dense materials. So if
Mhm.
you've got a very loud noise source, the same principle would apply here. You would need to have something that is quite heavy and dense to provide sufficient noise reduction. Now, if the noise is not that severe and maybe it's a high pitch um, noise that you just want to reduce a little bit, you could possibly put some insulation behind the louver door to reduce the reflected noise. One example, oftentimes louver doors are used on mechanical rooms. You might have a small closet in your house that
Really?
houses the air conditioner or the furnace,
Uh-huh.
and a lot of times the noise from that comes out through the louver door. That noise is not that loud and intense
Mhm.
as like traffic might be, or like let's say your neighbor's pool pump or generator might be. The noise from an air conditioner is much quieter than that. And so one thing I've done with HVAC or air conditioner closets is to, since you can't block off the louvers in that case because you need the airflow to go through. So we have put basically what is called a baffle behind the louvers, and you can set that baffle off with a couple of pieces of wood or steel that maybe set the baffle away from the louvers by an inch or two so you can still get airflow around. But then
Mhm.
that baffle has insulation facing the air conditioner unit, so it absorbs some of the sound and also blocks the direct line of sight. So
Mm,
it's not a full noise barrier, but it certainly does reduce the noise some.
I see. And is there also, I've heard different things regarding uh, the thing you need to put behind, like if you're going to soundproof the louver door or window, you need to put something on the door itself. Should there be a little distance between the materials that you're putting on so that there's some space in between them, or does that matter at all?
That can be helpful, yes.
How come?
Well, again, there's two considerations. There's the noise consideration and airflow. Um, Anytime you start to implement noise reduction, you have to think about what are the other impacts that might occur from that. And just like I mentioned, a lot of times louver doors are used because they need airflow, whether
Uh,
it's that air conditioner room that I talked about or even a closet. If you block off all the airflow to your closet, probably going to start to get mold and mildew forming because there'll be moisture in there. And so there's oftentimes there's more consideration to what kind of noise mitigation you use than just the noise. So the standing off of the insulation of the baffle can allow that airflow to happen while still providing you some noise absorption. The other consideration is sometimes an airspace can be a tool that you use to increase your noise reduction. So if you have a louver door and an airspace and then it's some sort of barrier or absorber, you may get a little bit better noise reduction than you would if you just apply that material right up against the door itself. The same principle applies with insulated windows. Oftentimes they leave an airspace between the two panes of glass in insulated windows, and that not only helps with the insulation factor, but also with noise reduction.
I heard it's because the energy of the sound, it transforms from going through a material and then as an airwave in the form of an airwave and then material. And if it changes that way, the energy form, that in itself reduces its energy. Is that more or less correct?
That is true, with a caution. There's always a caution with noise control.
Oh,
So that is true that going through different mediums does change the energy, and generally you will get more noise reduction. Let's say, for instance, two pieces of drywall. If you
mhm.
put two pieces of drywall together and glue them together, you'll get one amount of noise reduction. If you separate them by an airspace, you'll get better noise reduction. That's the principle of making a wall, right?
Yeah.
But there's also a phenomenon, now this is getting really technical, called the air mass resonance.
Oh boy.
And
Okay.
anytime you separate two pieces of material with an airspace, you have a potential of introducing a resonant frequency. Are you
Oh.
familiar with that term?
Well, I mean, I know what residence, yes, I know what those mean separately, but
Okay.
I've never heard them in this context.
So a resonance is any material has a resonant frequency. And what that means is, like, if you tap on a piece of metal, for example, you might have heard it ring. Or
Yeah.
if you clink two wine glasses together, you hear that ring, and the ring lasts for quite a while, right?
Mhm.
That's creating a resonance, which means the noise is, it's not taking much energy for that noise to transmit through the
Mhm.
air. And that's why the ring of the wine glasses together lasts for so long. It's a resonant frequency. Well, the same thing occurs when you have any two pieces of materials separated by an airspace. There's a resonant frequency associated with that. And that may not be a problem unless the resonant frequency happens to fall in the range of noise you're trying to reduce. So, for example, if you live in an apartment and you're hearing your neighbor next door,
Yeah.
if the resonant frequency of the wall between you and your neighbor happens to fall around, oh, let's say 500 or 600 hertz, that's in the frequency range that the human voice um, occurs. It's a wider range than just that. But if you happen to have a resonance at 500 hertz, all that sound of that voice is going to go straight through that wall without very much attenuation at all. So we have to be very careful when we design walls and barriers, and we offset one material from another, that we design them so that the resonant frequency is either very low or very high, so that it's not falling in a range that matters.
That's really interesting because I've seen kind of thick walls like this thick, and I still could hear pretty much every word from people on the other side of the wall, and that's because of that.
It may very well be. It's probably because of either that or leaks through the wall
That
at some
makes.
point.
Uh, so last question, what is the biggest mistake people do when they're trying to soundproof a louvered door or window, would you say?
Oh, that's a great question. I think the most common mistake I've seen is that people use lightweight materials, foam insulation or insulation bats and things like that,
Mhm.
um, which absorb reflected sound but aren't very good barriers. So, it depends on when I developed my shutters, I did some research online and people were putting what they called window plugs in their
Mhm.
windows. And that's basically a piece of foam or a piece of quilted material that they've cut out to fit the size of the window. But usually it was very lightweight because they want to pick them up and put them in the window. Well, anything lightweight is not going to be a very good barrier to noise passing through it.
I get you.
And that's it. Thank you for watching. If you want me to interview a soundproofing expert about a particular subject, then please let me know in the comments section below. And also, if you have a soundproofing question in mind, then let me know as well, and I'll get right back to you, hopefully with a new video as well. Also, like and comment and subscribe if you want to see more content like this. And until next time, take care.